We've got Liz Acosta here who's going to talk about testing strategies for Python. Obviously, everybody wants to test, and we're going to learn how to do it better.
Yes. Well, we're going to kind of take it back to basics, make sure we understand exactly what we're testing, what's going on. Hi, my name is Liz. Quick intro. I am a film and fine arts student turned social media manager and content creator turned software engineer turned developer advocate. While this may seem like a pretty unconventional path to tech, for those of us in the developer relations space, actually pretty typical. I love pizza, plants, pugs, and of course Python. And that's my senior pug, Gary, and his little cloud. I'm currently open to new job opportunities, so hit me up after this if you are hiring. So why this talk? So for about 5 years, I was a software engineer at Twilio. While I was there, I worked on a team responsible for improving the quality of code. Basically, what we wanted to do was reduce the number of developer-introduced bugs that were causing incidents and costing the company money, which is no bueno. What we found is that developers really want to do the right thing, right? Just like we all want to eat a balanced diet that includes our vegetables, but they didn't always know how to, they didn't always know where to start, and they didn't always have the right tools. As a result, testing became more of an afterthought, where developers were essentially just taking the existing tests, copying them, modifying for whatever they added, and not really giving it a second thought. So with this talk, what I'm hoping to do is inspire you to rethink some of your assumptions about testing and like the importance of testing and make it less of a chore. And I'm going to do that by kind of taking it back to basics. And yeah, we're going to get into that. So what is testing, right? Like as I was, researching for this talk, I really had to ask myself, what is testing? Like I think I know what it is, but do I really? So at its core, software testing is the process of evaluating and verifying that a software product or application does what it is supposed to do, right? There's lots of benefits to testing, right? It can help prevent bugs, reduce development costs, and improve performance. However, I think the most compelling benefit to writing tests is that it helps us write better code. When we're writing our tests, we're really forced to ask ourselves, what actually is the expected behavior of this method or this application, right? Asking ourselves that question can help reveal code smells and indicate when a method may need to be refactored or your entire system redesigned. There's lots of different kinds of testing that seeks to answer different kinds of questions. And I created this alignment chart to kind of illustrate that. Unfortunately, or fortunately, depending on your point of view, I don't have time to talk about all of these. So for today, I'm going to focus on the lowest hanging fruit and therefore your easiest testing win, which is unit testing, which I consider lawful neutral. And this is still open. This is open for debate if you want to talk about it, but I think unit testing is firmly lawful neutral. So what is unit testing, right? Unit testing is when we break code down into its smallest testable components. Typically, this means testing each method independently. You can kind of think of unit testing as checking the different ingredients and tools required for making an omelet. So it's like, do we have enough eggs? Are we including cheese in this omelet? Do we have a frying pan? Is it clean? Does the stove work? If we can verify all of these parts independently, we can be pretty sure that when we go to make our omelet, that it'll be a pretty tasty omelet. So for this demo, if the demo gods decide to grant us their blessings, I have a little Flask app that I've written. I'm going to use the built-in Python unit testing framework, conveniently called unit test, as well as the unit test mocking library and Visual Studio Code so we can run our tests in the editor. All right, so I have created a Build-A-Pug application where we give our app a pug name, a pug age, the pug home, and a time for puppy dinner. Oops. And because it's a requirement for everything these days to include AI, this application makes a call to OpenAI's API to then generate an image of a pug, hopefully not a weird one, sometimes they're kind of weird, based on that information that we gave it. So there's Lily. She's very strange. She has these roses here. Once we get our pug, we can perform one of the most important pug tasks, which is check to see if it's time for puppy dinner. Unfortunately, it is not. So this application relies on this pug class that I've created, where we give it a name, an age, home, time for puppy dinner. And once we have our pug, we can describe our pug. This description is what we use to build a pug. This is where that call to OpenAI happens. And then we can check for puppy dinner. So in our first test, I'm using unit tests, like I said. And unit test has this test case class that comes with a bunch of built-in methods and other tools and context managers to help us write our tests. So in our first test, we have our test case class. We go ahead and test. This is the happy path. And then here we use this assert equal method, which, like I said, comes with test case class, to then test that our test results match our expected results. So that's our basic class, our basic test right there. So our pug application has some error handling built in. Oops. 1 second. So that should be fine. It should work. Anyway, so for our Build-A-Pug, we expect, the class expects an age in an integer format and a puppy dinner in a 12-hour clock format. If any of these are not the right kind of value, then we get back this error for the application to handle, right? So in our tests, we'd want to test our error handling. And what we could do is we could write 2 separate tests, right? We could write one test that checks what happens if we give it the wrong age value, and then another test to see what happens if we give it the wrong puppy dinner time, right? And then test that the error handling operates as we expect. Now that's a little bit tedious and a little bit redundant, and what we're trying to do here is write more efficient tests and make the process a little less awful. So what this test case class comes with is this context manager called subtest. And what subtest does is tell unit tests, hey, set up just one test. I'm going to give it a couple different inputs to try out, but I want you to consider this one test. And if one of these inputs doesn't work, if the test fails, keep running the test and consider this one test. If I didn't have subtest in here, and let's say like one of these, my tests fail, then that's one whole test that fails, and then it won't continue with the rest of the input. So if you're trying to use like parameterization here, right, and if you're not using subtests, then that test would fail, and then the rest of the tests would also fail without subtests, right? Because it's like, oh, that failed, we're not using it anymore, it's not working. And that can be a bummer if you're trying to use parameterization to write more efficient tests. So that's parameterization with subtests. Then we're also asserting that the exception is raised. And then we're also using assert equal here to test that the exception message that we get matches what we expect to get. So that's that. So, like I said, don't worry, we'll get to running the tests. And can everyone see that okay? Okay. So we also have build-pug, right, which, like I said, makes a call to the OpenAI. So that's a real API call that costs real money, and we don't want to blow our budget testing Build-A-Pug, right? That's just kind of a bummer. So how do we get around that? Moreover, we don't need to test OpenAI. We're trusting that OpenAI has written their test and that their API works as expected, so we don't need to test it. And like I said earlier, What this makes us ask is, what are we actually testing here? What we really need to get back, right, is the image URL that we get back from that OpenAI response. So what can we do here so that we don't blow our budget? This is where that mocking library comes in handy. And you use that, you implement that with this patch decorator here. And what this is saying is, hey, unit test, for the duration of this test, I want you to replace this call with a magic mock object. And then I can take that magic mock object that comes with a bunch of attributes, and then I tell it, hey, I want the return value to be this mock OpenAI response. And this is testing exactly what the method is doing. We're calling the API, and we're expecting to get back an image URL from that response. So that's mocking. So we can run all of this in our terminal, right? But we are humans, and so making things human readable makes things a lot easier for us. So in VS Code, I'm using the Python plugin. With a little bit of configuring, you can get unit tests to run in here. And I'm going to do it here. So I have the option of running all my tests. I can run them individually. And then I can run them in debug mode. And so here's my debug controller here. And if we look at build pug, let's go to our next one. Hang on. We can see our magic mock object here. And this debugging can be really helpful when you have a method that has maybe a little bit of black box magic to it, and you don't quite know what's going on. And you can use debugging. I mean, there's a way to do it in the code. It's kind of tricky. This makes it a lot easier so that you can then put your breakpoints in and see what's actually happening, what you're actually getting for these values. And because I'm using a mock here, you can see that I'm using the magic mock. And there's the return value that we gave it. So yeah, those are the tests. And yeah, so there's a lot more about testing that we could talk about, but that is all my time for today. So in summary, we talked about unit testing. We talked about using parameterization and subtests to write more efficient tests. We talk about mocking so that we can control outside dependencies. And we also talked about using an editor to make our lives a little bit easier. All of this code is available on my GitHub. There's the QR code there. Feel free to pull it down, try it out, and then let me know what you think about it by reaching out to me on LinkedIn. And so thank you so much for coming to my talk, and enjoy the rest of your evening at PyBay. Yeah, questions? I feel like there's going to be some hard ones.
Cool. Thank you for the talk. Is that VS Code plugin that you showed for the debug mode, is that just like the standard Python plugin for VS Code, or is there something else for that?
Nope, that's pretty standard.
Okay,
Yeah.
cool. Thanks.
You will need, as I understand it, and I don't know if it's separate from running the test, but you might need to configure it to run with unit test. And all of your like IDEs and everything should include something like this. Anything else?
Oh, okay. Any more questions? Going once? Twice? Nobody?
I also have pug stickers if you want any. All right, thank you so much.